Hi guys, welcome to another video by TechCerts. We discussed some of neural network applications in our previous video. You can check it from right above corner or link is in the description. Now let's dive into furthermore applications that are related to text-based applications using neural networks. So one of the other text-based application is sentiment analysis. This is within text classification and is essentially to use natural language processing and machine learning to interpret and classify emotions in text information. Usually in the first step, text data needs to be cleaned from the noise, which includes removing URLs, email addresses, punctuation signs and stop words like I, have, are. Then transform the data into numeric tensors, usually referred to as vectorization, because deep learning models do not take raw text, they only work with numeric tensors. So these are some data pre-processing steps related to text-based predictions. Now it's time to transform it into floating point tensors, which is called as word embeddings. Also, sometimes it is called as word vectors. These are learned from data and essentially are low-dimensional floating point vectors that pack information in few dimensions. Why would you use this method and not any other different and more simple methods? Because deep learning models converge easier with these dense vectors than with sparse ones. Again, it always depends on the dataset, nature and the business you need. You can either use a pre-trained word embedding stack on top of your model or learn word embedding from scratch. One point is using recurrent neural networks to make text-based sentiment analysis easier. Because think about a scenario where you read a book. When you are reading, you keep in your memory what you have read in the previous lines, right? You have a sense of the whole meaning. This is exactly the same principle that RNNs adopt. They process sequence by iterating along the sequence elements and keeping information relative to what it has processed so far. This shows some best accuracy achieved models for sentiment analysis with the IMDb dataset. Here, as you can see, ExcelNet is leading the leaderboard. But sentiment analysis can be attempted with different neural network models such as average pooling, RNN and transformer type networks. You can use IMDb reviews and Twitter Sentiment 140 as your datasets. As a starting point, you can look at the GitHub repo mentioned in the description as well. We can dive into more and more about this later in our videos, but now let's move on to another text-based application using neural networks. The language translation, as the name suggests, we can use neural networks to translate different languages as Google Translate. Particularly, let's look at how transformers can be used in this machine translation method. As Google AI blog post explains, neural networks for machine translation typically contain an encoder reading the input sentence and generating a representation of it. A decoder then generates the output sentence word by word while consulting the representation generated by the encoder. The transformer starts by generating initial representations or embeddings for each word. Then, using self-attention, it aggregates information from all of the other words, generating a new representation per word informed by the entire context, represented by the filled balls. The step is then repeated multiple times in parallel for all words, successfully generating new representation. And this is a transformer model and its 4-layer neural network. But why are transformers significant? Transformers excel at modeling sequential data such as natural language. Unlike the recurrent neural networks, which is called as RNNs, transformers are parallelizable. This makes them efficient on hardwares like GPUs and TPUs. Also, unlike RNNs or convolutional neural networks, transformers are able to capture distant or long-range context and dependencies in the data between distant positions in the input or output sequences. Thus, longer connections can be learned. Attention allows each location to have access to the entire input at each layer, while in RNNs and CNNs, the information needs to pass through many processing steps to move a long distance. which makes it harder to learn. Also, transformers make no assumptions about the temporal or spatial relationships across the data. This is ideal for processing a set of objects. So, you have now basic idea why transformers are popular in language translation. Large language models are a type of artificial intelligence that use deep learning techniques to analyze vast amount of data, including text, images, and audio. They are based on neural networks. One popular such model is called ChatGPT, which is developed by OpenAI. By querying the LLM with a prompt, the AI model inference can generate a response, which could be an answer to a question, newly generated text, summarized text, or a sentiment analysis. So how does it work? At the foundation layer, an LLM needs to be trained on a large volume of data that is typically petabytes in size. The training can take multiple steps, usually starting with the unsupervised learning approach. The benefit of training on unlabeled data is that there is often vastly more data available than labeled data. At this stage, the model begins to derive relationships between different words and concepts. The next step for some LLMs is training and fine-tuning with a form of self-supervised learning. Here, some data labeling has occurred, assisting the model to more accurately identify different concepts. Next, the LLM undertakes deep learning as it goes through the transformer neural network process. The transform architecture enables the LLM to understand and recognize the relationship and connections between words and concepts using a self-attention mechanism. That mechanism is able to assign a score, commonly referred to as a weight, to a given item in order to determine the relationship. Once an LLM has been trained, a base exists on which the AI can be used for practical purposes like chatbots. If you enjoyed this excerpt, please like and share. If you have any suggestions, feedback, or questions, don't hesitate to comment. And to stay tuned, please subscribe and hit the bell icon. See you soon.